I think we're recording now. Okay. So hi. Hi, everyone. How's it going? Yeah, so all right. Hey, it's our last class before Thanksgiving break. I mean, this class. We probably have other classes, but that means you must be really excited about doing math today, because you're not going to get to do math with me for like 10 days. I know it's very upsetting. So really, I just wanted to do some power series practice today. And then maybe at the end of class, I might start talking about Taylor polynomials. But so there's this handout on the handouts page called Power Series Practice. So please download that especially if you're remote, or if you want to work on it on your Zane No Frills handout, just basically some problems to do. And so let's see, we did a problem very much like number 2 yesterday, or Monday in class. Remember, the idea is that a power series is an infinite series that has a variable in it, and that you want to find the values of x for which the series converges. And the best way to do that is to use the ratio test, because we're always going to have an exponential function in here. And the ratio test is good because we always have some sort of variable to the nth power, the ratio test is good for that. And let me just maybe say on the board real fast, just to remind you where we were with this, that the idea, right, was that there's always this center of convergence, kind of the point where where the power series is kind of dumb, like the x's basically go away. You guys remember that from last time? So power series. I mean, I can write some general things. I didn't really write general things last time, but I think the book sometimes will write something like this: Cn x minus a to the n equals 0 to infinity. So Cn is some function of n, and then you have this, x minus a. And so like x equals a is the center of the convergence. That's called the center, because that's the thing that, like, when you plug in a here, pretty much all the terms of the series go away. It's not even an infinite series anymore. So that's where the point where it obviously converges, right? And then, so you get this point in the center where it definitely converges, some sort of x-axis. And then what we found is that it's kind of neat that it actually converges sort of equal distant from the center. So you'll get some interval of convergence, sort of plus r minus r, away from the center. And that r could be infinity, it could be 0, there's different cases. But then you end up with some sort of interval of convergence here. So this is the radius of convergence, which, remember, we find using the ratio test. And we set the output less than 1. Remember, the ratio test spits out a value, and if that value is less than 1, then the series converges absolutely. If it's greater than 1, then the series diverges. And then we check the endpoints. Check the endpoints explicitly, because the ratio test doesn't tell us what happens to those endpoints. And then sort of the final answer is the interval of convergence. I mean, because you want to know exactly where this converges. So it's always of the form like, a minus r to a plus r, with one or both endpoints included, right? So like it could be like that, it could be like this, it could be like this. the right endpoint included, or it could be with both endpoints included. Right, those are sort of the four options, like neither endpoint included. Remember, the square bracket means include the endpoint, and the parentheses means don't include. Yeah, parentheses means don't include. Okay. And so when we get into this Taylor series stuff, which I sort of mentioned at the end of class last time, about this sort of magical thing where you get these infinite polynomials that you can actually use to replace complicated functions and then cut them off and use a finite polynomial to approximate complicated functions. It's going to be important to know where these converge. Okay. You should have in your notes like the big example that we did last time where we went through all the details. And it was very much like number 2 on the handout. So I think what I would have you do is just do group work starting from number 1. You could skip number 2 and come back to it if you want. And then do like 3, 4, 5, 6. That sound like a party that everyone's invited to? Reasonable? Let's get up into groups. Do it. Let's do it. Who wants to be in groups? All these people who aren't here today, but groups. Can you 5 figure out some groups, and then you guys can all figure out some groups? Yeah, and then for those of you on Zoom, you can work and yeah, please go to the boards and start number 1, and then skip number 2 for now, because we kind of did an example just like that. And then do 3 and 4 and 5 and 6. Those of you on Zoom, I'll just try to watch the chat. You guys can like chat with each other. And I'll probably come back and do answers later in class just to go over them. So, okay, I'll pause the recording. Resume the recording and say that here's what goes on with number 1. This is what the group work students did. You can pause the video here and look at it if you want. Just talk to the camera. But I'll do 3. I'll do number 3 now because all the groups here got through number 3.
Yes. So we're struggling. Yesterday was bad. Friday was bad. Yesterday.
I thought you guys weren't supposed to come to class when you're sick. I mean, I like having you here, but
The issue is like it's all a deal on that of don't come to class and like you'll be fine. You can make it.
I've been watching the Zoom.
Yes, for this class. For
Yeah.
classes, like I have a class that's like it's all discussion based in class, and if you miss one class, you miss a whole like section of like subjects.
Oh yeah.
You can't make those up. So it's you can't miss it.
Yeah.
And like that happened in high school as well. They're like, don't come to school if you're sick, but it's like not feasible.
Pressure is always on.
I never missed a day of high school.
Just in case that's not clear, that's just A7 plus 1 over A sub n. And we get lots of cancellation. The n cancels there. That cancels like that. So this actually doesn't even have an n in it, so the limit's just, which I could also write as that. And then we set it less than 1, right? So that means absolute value of x plus 1 is less than 3, which means that x plus 1 is between 3 and negative 3. Subtract 1 from all these. So we get that. We draw this on the number line. There's minus 1 the center. There's minus 4. There's 2. So we can see that r is 3. And then the endpoints we have to check explicitly. So if we try 2 up there, we get 3 to the n over 3 to the n. It's the sum of 1, which is 1 plus 1 plus 1 plus 1, so on. If we try negative 4, we get negative 3 to the n over 3 to the n, which is negative 1 to the n, which is 1 minus 1 plus 1 minus 1, and so on. So these both diverge. So the answer really is negative 4 to 2. Okay, so that was number 3. Yes, I can try. Might pause the recording again. Oh, did you get an endpoint finally? So when x equals 0, all the terms of this series go away, right? So it definitely converges there. So that's the center. So I'll write down the n and plus first, n and n plus first terms, and do the ratio test. So we get cancellation again, right? Hopefully we're getting to realize that this is going to go to 1. So we just get absolute value of 5x less than 1. So now we have this. So the center is 0. The radius is 1/5.
So
And what happens at the endpoints? If x is 1/5, then we get the sum of 1 over root n, which diverges. That's the p equals 1/2 p series. If x is negative 1/5, we get negative 1 to the n over root n. And that's the classic alternating series that goes back and forth, smaller and smaller. So alternating series test shows that this converges. We finally got an endpoint. Okay. So I think that's the answer right there for the interval of convergence. Radius was 1/5. The interval is negative 1/5 to 1/5, but with the left endpoint included. Let's see how other people are doing.
I was just basically looking on the last part there. So this converges because I know my handwriting is awful. I'm just, yeah.
Well, that's p-test, right? And this is just classic alternating series where the terms are going to 0, getting smaller and smaller. So it converges. Good job. All right. You try the endpoints on this one?
This one?
Yeah.
This would just approach one, right? As it
Right.
gets closer to infinity, so that would be 5x. And then to make that less than 1.
Right. But what about the endpoints?
That'd be 1 to the n over. That approaches infinity.
Yeah, well, that's a,
But that is less than 1 over n.
yeah, that's a p-test, p equals 1/2. So that diverges. What about negative 1/5?
Negative 1/5.
Negative 1. That would oscillate.
That's a classic alternating series. The terms going to 0,
Yes. Yeah.
and now they're getting smaller. Yeah. So that converges.
So both of them?
No, 1/5 diverge because that was p. Right.
This,
That was p less than 1. That one converges. Yeah. All right. Maybe we should come back together just to talk about a few of these. Yeah, so I hope people on the Zoom have been trying these on their own. You can hear me talking. Did I mute myself? No, okay. So I wrote 5 on the board. So this is probably. So maybe everyone, if we can just kind of come back. I know you want to talk about course selections, but and round 2. But oh, sorry, let me go. Yeah, so number 5 I put on the board here, but most groups seem to get there. That the ratio test spits out just absolute value of 5x, which puts x between minus 1/5 and 1/5. If you draw it, right, that tells you the radius is 1/5 because the center is 0. And if you actually check the endpoints, when you plug in 1/5, you get 1 over root n. That's just your classic p series. So p equals 1/2. And if you plug in minus 1/5, you get minus 1 to the n, which is your classic alternating series. You know, like a p series with all positive terms, there's a condition of whether they converge or diverge. If it's a p series, but it's alternating, I mean, we don't really call it a p series, but if it's like an alternating type p series, those always converge because the terms are always going back and forth and getting smaller and smaller, right? As long as it's 1 over some power of n. Okay, so that now we actually got an endpoint that converged. So we got negative 1/5 is part of the convergence and 1/5 is not. 6 I wrote out just in terms of just the terms because it's nice to practice putting things into summation notation. But I was thinking, I don't know, do you want to have movie time? Should we watch a movie? Hold on. It's gonna be math. Oh. Oh, I have no idea if the audio goes through Zoom. Probably doesn't. Can I control the volume? Oh. Wait, hold on a sec. Let me, if you're on Zoom, I don't know if the audio comes through. So let me just put the link in the chat. That seems to be maybe, so you can watch this. But I do want to, this is the only math YouTube channel I really like. I'm pretty picky. This 3 Blue 1 Brown. Did I have you guys watch some of this already this semester? Oh, I talked about the 1/n² video the guy did. But he does this really beautiful video about Taylor series. So I just thought maybe we'll do a little movie time. But I put the link to the YouTube video in the chat because I don't know if people on Zoom can hear it. But so you might just want to watch it there. Let's just watch some of this. You don't necessarily have to watch the whole thing. But yeah, this guy makes nice videos. So.